Hello everyone, we will be solving today the problem least common ancestor from interview bit. So the problem statement is something like this. Find the lowest common ancestor in an unordered binary tree given two values in the tree. So we will be given an unordered binary tree having tree node A and values B and C, and we need to find the lowest common ancestor of the value B and C in the tree A. So what is an LCA? The lowest common ancestor LCA of two nodes V and W in a tree or directed acyclic graph is the lowest, that is the deepest node which has both V and W as descendants. So what does this mean? Let us understand from an example. I have already made a graph here. So in this graph, if I ask what is the lowest common ancestor of 4 and 5 will be. So the lowest common ancestor of 4 and 5 will be 2, because 2 is the deepest node from which both 4 and 5 is reachable. So what is the meaning of deepest? So we in a given tree we can have depth of any node. So depth is something like this. The root node has depth 0. Its children will have depth 1. Their children will have depth 2, and their children will have depth 3, and so on. We will carry on this something like this. Okay. Since 4 and 5 was reachable from both node 1, I can reach 4 from node 1, I can reach 5 from node 1. My 1 is not the answer because it is not the deepest node from which 4 and 5 can be reached. Which is the deepest node from which 4 and 5 can be reached? 2 is the deepest node from which 4 and 5 can be reached. Let us take one more example. If I take example of 5 and 8, what is the LCA? The LCA will be 1 because 1 is the deepest node from which 5 and 8 can be reached. Okay. Let us take one more example. If I take example of 6 and 7, 6 is the node from which both 6 and 7 can be reached. I can reach 6 from 6 because I am already at the node 6, and I can reach 7 from 6. I took this example to show you that one of the value can also be the lowest common ancestor. So this is it. Since we have understood what is lowest common ancestor, now we have to check how to find the lowest common ancestor. So one of the brute force method would be to check from every node is value 1 and value 2 is in the subtree or not. For example, I will do a depth first search, and from every node in the DFS I will try to find out that both the value 1 and value 2 is present in the subtree or not. Basically, I will be doing a depth first search in a depth first search. What does this mean? First, I will go to node 1 and I will check, is my value 4 and 5 there? Yeah, value 1 and value 2 is present here. I am taking here example of 4 and 5, that's why I am calling it 4 and 5. Yeah, both 4 and 5 is present here, so my current answer is equal to 1. Now I am going to its children. From the subtree 2, is both 4 and 5 present? Yes, in the subtree 2, both 4 and 5 is present. So I am updating my answer to 2. Now I am going to their children. In the subtree 4, both 4 and 5 is present? No, only 4 is present. So I am not updating my answer. And similarly, I will go to 5 and their nodes. So I will not get any of the answer in which both 4 and 5 is present. So this was my final answer. So this was the most brute force solution. Okay. What will be the space and time complexity for this? The time complexity will be equals to n square. Why n square? Because I am doing a DFS, and from every node in the DFS I am once again doing DFS to find whether both A and B, value 1 and value 2 is present in the subtree or not. What will be the space complexity? Space complexity will be O of 1 because I am not using any space. Okay. Now, how to optimize it further? To optimize it further, what we can do, while traversing, we can store the path of the values. For example, I am taking here example, let us take another example. Let us take example of 5 and 8. Now, I will search for 5. If I am traveling for 5, I will try to find the path of 5. When I am traveling for finding 5, I will get a path something like this, 1, 2 and 5. How we will find it is not a matter now. We are just doing the algorithmic part right now. We can understand how the code will write. We can understand how we can write the code for this. Okay. So and while finding 8, what we can do now? We are finding LCA for 5 and 8. Now while searching for 8, my path will be something like this. My path will be this one, 1 3 8, 1 3 8. So these are two vectors which I have got while searching, making the path. Okay. Now it is clearly seen that 1 is the last node from which both 5 and 8 is reachable. 1 was the last point of intersection in the path from where both 5 and 8 was reachable, hence 1 will be my answer. The LCA of any two nodes in a given tree will be the last intersection point. Basically, that was the answer. And let us take one more example. If we consider the case of 4 and 5. Once again, let's take 4 and 5. My LCA path will be 1, 2 and 4 while searching for 4, and my path will be 1, 2 and 5 while searching for 5. As we can clearly see that the last point of intersection was 2, hence my LCA for 4 and 5 will be answer 2. Now let us understand how we will be writing code to find the path. Okay, so void path, I will be taking tree node star a root and integer value and vector of int and b. Okay, just let me rename the variables root a and b. Okay, now I have just renamed the variables. What I will check, if I have already at the null, I have reached to the end of the tree. If root is equals to null, I will just return. Okay, else what we will be doing, we will be, if where I am currently, if I am my root val equals to val, then what I will be doing, I will just v dot push back val. So I am doing v dot push back val. Now before this, I am also traveling to the children. DFS root left val and v, and DFS root right val and v. What I am doing is, I am traversing to the children, and again then after returning back, if I am checking that if I am at the position where my root value is equal to value, then I am pushing it. And now when I am going to the parent, now when I am going back now, if my let me write it here. If my v dot size is greater than 0, if my v dot size is greater than 0, then I can v dot push back root val. So what this function is doing, we have to understand first. What this function is doing is, first I am checking if I am at null or not. If I have reached to the end of the tree, then I am just returning, or else I am just going to the children, and if I have found any, if my size is full, if size is not equal to 0, that means that I have already found such a path or few nodes from which I can reach to the end. And if I have found few nodes, it means that I am parent of that node, so I am basically pushing it, and then I am going to just checking that if my root value is equal to value or not. So what is doing, let us do a dry run here. When I am finding the path for 5, what I am doing, first I am going to the children's, I went to this path and this here, then I am going here, then here. Now I am checking that is my value is equal to 5. Yes, my value is equal to 5. Then I am returning here, and then while checking, now my current vector is something like this 5. Now it is filled, it is not empty. So I will push 2 here, and while again backtracking to 1, I will again push 1 here. So this was the basic logic behind how we will be storing the path. And after we have stored the path, we can check for the last element which is common to both of them. Now here is a catch in the problem. In the problem it is given that there is no guarantee that value 1 and value 2 exist in the tree. If one of the value does not exist in the tree, we need to return -1. If any of one of the value is not present in the tree, that means there is no path. The path size, vector size will be equal to 0. So we can check that if my vector size, path dot size, or vector v dot size equal to 0, then I will just return -1. I will return -1 in my answer. It means that value was not present in the tree. Now what will be the space and time complexity of this problem? The time complexity for this problem will be O of n, because we are doing DFS twice, or O of 2n to be precise, and space complexity will be equals to O of 2n, because I am storing path of all the path of both the values. Okay, so space complexity will be O of 2n and time complexity will be equal to O of 2n. Now, is there any scope of optimizing it further? What we can do, there is a scope where we can optimize the space of this code. How we will be doing? Basically, I will be traversing. Let me erase it first, then I can make you understand better. Yeah, while traversing, I will write a recursive code in such a way that I will ask that is Do I have an LCA to the left of my tree? If I have an LCA to my left of my tree, then I will return LCA to the left. I will return the left. I will find the LCA to the right of the tree. If I have LCA to the right of the tree, then I will return right. If I do not have LCA to any of the left or any of the right, then I will return my current root node value. Why? Let me make you understand better. For example, if I consider the example of 4 and 5 here, I will check in root 1 that do I have an LCA in this left tree? Yes, I have 2 as my LCA as the left subtree. So I will be returning 2 here. And did I had any LCA at the right subtree? Since I do not have any LCA at right subtree, so I will be returning nothing from here. And this will be my solution. So if while writing the code, I can make you understand in a better way, because this is such a code where you can understand it better while writing the code, not by this tree diagram. So how we will be doing is that before that we need to check that whether both A and B is present in my tree or not. So what I will be doing is that I will be writing code bool is present tree node star root comma integer val. If my root is equals to null, then I will be just returning false, and if my root value equals to val, then I will be returning true. Return DFS or is present root left and value or is present root right value. Okay, so what I did here, I am checking is it is present in any of the left subtree or not, or any of the right subtree or not. Okay, so it will give me that it is present here or not. So if is present, let me just rephrase it. I'll just write here root and A and B here. If my if it is not present here, if I'm not finding A in my root is equals to false, then I will return -1. And similarly, if I am not finding B in my subtree or in the tree, then I am just returning -1. Now after this point, I am pretty sure that both A and B is present in my tree. So I can write a function here, integer LCA, which will give me the LCA to this question. So tree node star root integer A integer B. So if my root equals to null, I'll just return int min. This int min is just a flag to check that I didn't find any of the values here. So if my root value is equals to A or root value equals to B, return root value. Okay, and if I have found now integer left will find my LCA to the left of the tree, and similarly my right will find to the right of the tree, and after finding I'll check if my left is equals to int min, then I'll just return right. If my right equals to int min, I'll be returning my left, or else I will return root. Okay, let us first run this code, and then I will explain you in a better approach. Okay, let's see why I'm getting -1 here. Return the following. Okay. So is present root A equals to false. Yeah, this should work, but why is it giving me yeah, it is giving me -1 and return LCA. I have just not wrote the function root A and B, and now let's check it what it is giving me. Yeah, it passed the test case. I have just not returned the value only. Okay, first submit it and check whether the cases has passing or not. Okay, the code has got accepted, and now let's understand how this code is working. This code, I think it is understandable to all that we are finding is my value 1 and value 2 is present in the tree or not, and after that I am writing this code. In this code what I am doing is this, that first I am traversing, I am checking that if I have found, for example, I am at node 4, I am finding the answer for 5 and 8, okay, LCA for 5 and 8. When I am at this node, I am giving it int min because I have not found here. In 5 I am returning 5. This is int min. For example, let me denote int min by x. I am returning x from here and I am returning 5 from here because I found 5. In the code I have written it like this, that if I have found the value either a or b, then I am returning the value, or else I am returning int min if I have not found anything. Okay. Since I found, and then I am checking that if my left is int min, then I am returning the right, or my right is int min, then I am returning left. At this position, my left is giving me int min, so I am returning left here, so I am returning 5 from here. And from here, this position I am returning x, from this position I am returning x, and from this position I am returning 8. And here I got in my left as int min, and from right I got 8. So one of the position I have got, so I am returning 8 here. Now I am at 1. In my left subtree I have got 5, in my right subtree I have got 8. So I am checking here that is my left is int min? No, my left is not int min. Is my right is int min? No, my right is also not int min. So any of the thing is not int min. So the node which I am currently standing at, that will be my answer. So my answer will be equal to root value. Okay. So basically this was the solution for this problem. I hope it was understood to all of you, and if it was helpful to all of you, thank you.